Hi, this is Mrs. Lehman here with my 6th period math class.
Hi.
Today we're going to do lesson 2 from the modules. Actually, it's lesson 3. We're going to talk about equivalent ratios, but before we do that, we're going to go over our bell ringer, a little review of yesterday's lesson. So, the first thing says, write the ratio of stars to circles in 3 forms. So, raise your hand if you can tell me what the ratio of stars to circles. Oops. Stars to circles. Go ahead, Nadia.
4 to 3.
4 to 3, very nice. Now, how do you want me to write that? Fraction form? Okay. So, I'm going to scribble that out. 4 to 3. Nice job. How else can I write that, Malaya?
In the 2 form,
What do you mean?
like where you write like the word 2.
Very good. So 4 with the word 2, and then 3. And the last form, Michael?
4 ratio 3.
Okay, and actually you use a colon there, and that is the ratio form of that. So you remembered that. Nice job. Why would it be wrong to write 3 to 4? Why would that be wrong, Jacob?
Because you need to do it in the order the sentence says.
Very good. And this one says stars to circles, so we have to put the number of stars first. Nice job. Write the ratio of circles to stars. So what would that be, Stephanie?
4 to
Careful.
3 to 4.
3 to 4. Very good. 3 to 4. Nice job. Now you could have written it in any of these forms up here, but I chose ratio form for this. Okay. And the last question, write the ratio of stars to totals. Stars to total. So my first number of that ratio is going to be what, Joey?
4 to 7.
4, and then you gave me the last number 2. The total number shapes was 7, so that ratio is 4 to 7. Do we have any questions on this?
No.
All right. We are now moving on to our homework from yesterday, which is on page 4 of the module. First question 10 says, at the 6th grade school dance there are 132 boys, 89 girls, and 14 adults. I hope you underlined that. Part A says, write the ratio of the number of boys to the number of girls. So you can tell me what they wrote for 10A. Cam.
132 over 89.
Okay, you did it as a fraction? Yeah. Over 89. So you could have written that. You could have also written that in ratio form like this, with the colon. And you also could have used the word 2. Right? We already talked about question 10B not being necessary because we already wrote it in all 3 forms. Part C, write the ratio of the number of boys to the number of adults. Jordan.
132 to 14.
Very good. And you could have placed any of the forms in whatever column, but as long as you have all 3 there. Oops, I wrote that in the wrong section. And then, that's wrong. There we go. I'm just going to slide that down there. And you would write it in the other 2 forms as well. Let's move on to 11. In the cafeteria, 100 milk cartons were put out for breakfast. At the end, 27 remained. Now, we have a missing piece of info because in part A it says, what is the ratio of the number of milk cartons taken to the total number of milk cartons? Well, it doesn't tell us how many are taken, so I guess we can't solve this problem, right? Just kidding, we can. What do we need to do, Brianna?
You need to take 27 away from 100 to get your number that you need for this.
Perfect. And what do you get when you subtract 27 from 100? Cassie?
73.
Nicely done. All right, so we know that 73 were taken. So now it says taken to total, so who can give me that ratio? Riley.
73 total.
Okay. Very good. Who had 73 over 100? Nicely done. Let's do part B. What is the ratio of the number of milk cartons remaining to the number of milk cartons taken? All right, so remaining is first. Aiden, what did you get for that?
27 over 70.
Very good. Nice job. Who got that one correct? Good job. Right, we are now on lesson 3, equivalent ratios, which is on page 5. So we're going to skip exercise 1 and go straight to exercise 2. So let's read that. It says, Shani and Mel are using ribbon to decorate a project in their art class. The ratio of the length of Shani's ribbon to the length of Mel's ribbon is 7 to 3. So again, the ratio of the length of Shani's ribbon to the length of Mel's ribbon is 7 to 3. What should I underline there? Stephanie.
Now you're in, yeah. Now you're in 7 to 3.
What other piece does she need to underline? Jordan?
Shani's ribbon, Shani's ribbon.
Very good. So who does the 7 belong to, Shani or Mel? It says the ratio of Shannon to Mel's is 7 to 3. So the 7 belongs to who? Shani, yeah. We are in charge now of making a tape diagram. So who remembers doing tape diagrams from 5th grade? Right,
I didn't learn that.
You didn't learn them? Okay, that's all right. This is a really simple tape diagram that we're going to do. So we're going to label this S for Shani, and we're going to draw a bar, a rectangle, like that, okay? And that represents Shani's ribbon. So how many sections should I divide that into? 7, very good. So if you draw 6 lines, you will have 7 sections there. 1, 2, 3, 4, 5, 6, 7. Your units don't have to be exactly the same size, but they should be generally the same size, all right? We're going to do the same thing for Mel's. For Mel's, we want to start at the same place, okay? And how many over am I going for Mel's? Cassie?
3.
3, very good. So I'm only going to go to here and then stop it and make that tape diagram for Shani and that one for Mel. We're going to expand on this problem a bit because you already drew the ratio of 7 to 3, but now we're going to take this a step further. So we know that for every 7 units of ribbon that Shani has, Mel has 3. So if we were to write Shani to Mel as a ratio, that would be 7 to 3 if we write it in fraction form. What if each unit, however, instead of just being 1, was maybe 2 inches? What would I do with the 2? You guys remember doing this, putting it in the box? Right? So each section is worth 2. And every unit is worth the same amount. So in this case 2. So Shani's ribbon is 7 sections of 2, and Mel's ribbon is 3 sections of 2. So we are setting up an equivalent ratio. So instead of having 7, Shani now has what? Jacob?
14.
14, good. How did you get that?
Because there are 7 boxes and each one has 2. If you multiply 7 times 2, you get 14.
Very good. So to keep this an equivalent ratio, we need to multiply the top and the bottom by the same thing. So Mel has 3 groups of 2, so times 2. 3 times 2, everyone is 6. Yep. So that ratio is 14 to 6. Does that have the same value as 7 to 3? Yes, it does. If ratios simplify down to the same simplest form, they are considered to have the same value. They are equivalent ratios. Okay? You guys did ratios a lot in 5th grade when you were doing fractions. All right? You did equivalent fractions in 5th grade. Now we're just changing them to ratios and expanding that a bit. So let's do another one. So our ratio is 7 to 3. Who can give me another example of a ratio that has the same value as 7 to 3? Victoria, you want to try?
What's the question?
Can you give me another ratio right here that has the same value as 7 to 3? All right, she's passing. Aiden.
So if you multiply each number by 3, you would get 21 nuts.
Very nice. So he's going to multiply both the top and the bottom by 3. So 7 times 3 is 21, he says, and 3 times 3 is 9. So that also works. Does someone want to give me another one? Michael.
28 else.
28 over 12. Very good. What did you multiply by?
4.
Nice job. All right, I'm going to give you a ratio. I want you to tell me if this ratio has the same value as 7 to 3. All right? So if Shawnee has 70 inches of ribbon and Mel has 29 inches of ribbon, does that have the same value as 7 to 3?
No.
No, it does not. That is not equivalent, okay? It does not simplify down to 7 to 3, therefore it is not an equivalent ratio. We are now on lesson 3, equivalent ratios exit ticket, which is on page 7 of your module booklet. The question says, Pam and her brother both opened savings accounts. Each begin with a balance of $0. For every, that's a ratio alert. When you see the word for every, we know what is coming up next in the sentence.
Ratio.
Very good. So for every $2 that Pam saves, her brother saves $5. Who's better at saving money, Pam or her brother? Stephanie? Her brother, yeah. So if she puts $2 in the bank, how much is he putting in the bank? 5. So what's the ratio that describes the money in Pam's account to the money in her brother's account? Victoria?
2, 5.
2 to 5. Yep, you could write it like this. 2 to 5. You could write it like this. Or, you could use the word 2. Alright, so any of those are fine. Now, question 16 says, if Pam has $40, how much money does her brother have? Use a tape diagram. We're actually not going to use a tape diagram right now. We are going to set this up in something we call a proportion. That's when you set two fractions equal to one another, two ratios. So we know our original ratio when we're talking about Pam to her brother. This is Pam. This is her brother. The ratio Victoria told us was what?
2 to 5.
2 to 5. Good. Now we also have added to that we know Pam has $40. So where do I put the $40? Would I put it as the numerator or the denominator? Riley. Very good. We're going to put it right up here with Pam because everything having to do with Pam is going to go on the top. Right? So now we have to figure out how much her brother has, which is this missing piece. How would we go about doing that? What do you think, Cam?
Multiply.
Multiply. So what am I multiplying 2 by to get to 40, Jordan?
It's 20.
By 20. Very good. Once you figure that out, then you know we are doing the same thing down here. So 5 times 20 is 5 times 20 is What, Jonathan? 100, very good. So we're not done yet. We have to write that in a sentence. So who can tell me the sentence that says how much money her brother has? Brianna?
Phil Brothers has $140. No.
Pam's brother has, now Pam has 40, right?
Oh, her brother has it.
Her brother has $100. Does that make sense to everyone?
Yeah.
You do not want to leave it as a fraction here because he doesn't have 41/100ths of a dollar. He has $100, okay? So we'll take that info out and make that sentence. If we take a quick look at your homework before we wrap this up, you have to write two ratios that are equivalent to 1 to 1. So for example, when I have 20 students in class, I expect them to each have a pencil. So the ratio of students to pencils I expect to be 1 to 1. Notice, the front number and the back number, or if it was written like a fraction, the numerator and denominator would be exactly the same. Yeah, they're equivalent. So if I use the pencil example, if I had 50 students, 50 pencils, right? Can you guys come up with two other ones? Right, that's your homework for that. Write two ratios that are equivalent to 3 to 11. I recommend you using fraction form on that. Find out two more, all right? Scale that up. And then this one asks you for the width and the height, right? So obviously this is the height, this is the width. And then if each square has a side length of 8, you're going to have to figure out what is the width and what is the height. Are there any questions? All right, thank you guys. Don't forget to like and subscribe my page, as Aiden would remind you. Have a good day. Bye.